Okay, so this is where we had left off. So for this one, again, we have sine of alpha minus beta. So that's going to be sine cosine minus cosine sine. Right? So this is going to be sine of the first one, cosine the second one, minus cosine of the first, sine of the second. Okay, so here, immediately we could see that this is a half, and that's all that we could do right off the bat. All right, going here, we have a triangle, and there's an angle, the tangent of which is x. So here, this is x squared plus 1. So now, the sine of that is x over the square root of x squared plus 1 times, we have the half from here, minus here. This is cosine of arctangent of x. So it's the same triangle here, except now we're going to take the cosine, which is 1 over the square root of x squared plus 1 times, okay, now what about this one? It says here there is an angle, the cosine of which is a half. Now I know that the angle for which the cosine is a half is pi over 3. So the sine must be root 3 over 2. So now, denominators here are 2 root x squared plus 1, and on top I have x minus root 3 over 2 square root of x squared plus 1. So this is 2 root x squared plus 1, and on top I have x minus 3. Okay. Here it says to verify, that means to show that cosine of negative theta is the same as cosine of theta. So remember we had learned in section 1 the odd-even identities. So sine of negative theta is negative sine theta, and cosine of negative theta is cosine theta. Well, here it's asking us to show, to illustrate that this is true. So here's how we do it. Whenever we have to verify identities, the convention is that this equal sign stays in the same level. So here we're going to have the equal sign, and then we work to the left and we work to the right. So this cosine of negative theta, I'm going to rewrite it, right? So how do we write negative theta? How do we write negative 3? Well, negative 3 is the same as 0 minus 3. So here I can write 0 minus theta. That's the same as negative theta. Okay? So continuing to work only on the left, this is cosine of alpha minus beta. So it's going to be cosine, cosine, sine, sine. Cosine, cosine, plus, that's the identity, sine, sine. Now, sine of 0 is 0. That means this entire thing is 0. Cosine of 0 is 1. So what I have here is 1 times cosine of theta, which is just cosine of theta. And that equals, from here, cosine of theta. So you see that this is how we could prove the identity. Okay, here's one more. I have cosine of theta minus pi over 2 is equal to sine of theta. Well, okay, I could do the same thing. Equal sign stays here. Cosine of alpha minus beta, that's cosine, cosine, sine, sine. Okay, once again, cosine of pi over 2 is 0, so this whole thing is 0. Sine of pi over 2 is 1, so what I have here is sine times 1, sine of theta, equals sine of theta. So I was able to make the left equal to the right. Here I have a similar situation. All right, I have cosine of alpha plus beta, sine of alpha minus beta. So in essence, I have a separate identity here and then another one there. So let me just tackle this one. This is cosine of alpha plus beta. So I'm going to have cosine, cosine, switch the sign, and then sine, sine. Okay, minus. Now I'm going to work on this one, but I have to put it in parentheses because of the minus sign. This is sine alpha minus beta, so it's sine, cosine, cosine, sine, and that equals 0. Okay, well, let's see what we have here. Let me distribute the negative. So I have cosine x, cosine pi, sine, sine, minus, plus. Okay, let's see what we have. Cosine of pi is -1. Sine of pi is 0, that goes away entirely. Cosine of pi is -1. Sine of pi is 0, so that goes away entirely. From here, I have negative times cosine of x. From here, I have minus sine of x, so plus sine of x is equal to 0. Now, this is a very special, specific sort of equation. The best way to do it is to think about this mentally. If I were to bring this cosine over to the other side, I have sine x equal to cosine x. And then I think to myself, for which angle, which specific angle is sine of x equal to cosine x? Well, that is pi over 4. All right? Well, is there another one? Let's see. So here, for pi over 4, you have 1 over root 2, 1 over root 2 for sine and cosine. Here, cosine is negative, sine is positive. Here, cosine is negative, sine is negative. Here, cosine is positive, sine is negative. So the ones for which they're the same are in these two quadrants. So x is pi over 4 and 5 pi over 4. All right. Next one, it says to expand this formula. This is a direct application from calculus. We're going to revisit in chapter 12. So I'm going to label this g of x in order to make it easier for us to differentiate. So g of x is f of x plus h minus f of x over h. Okay, so what am I given? I'm given f of x. All right, so let's just explore that for a minute. F of x is cosine x. Okay. What would f of a be? Cosine of a. Replace x with a. Well, what would f of x plus h be? Cosine of x plus h. Okay, let's use that here. So g of x is f of x plus h minus f of x over h. Well, what's f of x plus h? That's cosine x plus h minus f of x, which is cosine of x over h. Okay, so what now? Notice this is cosine a plus b. So this is cosine, cosine, sine, sine, minus cosine x over h. And that is how we can leave it. All right, so this is the homework due Friday.